I'll be taking you through this simple topic here. It is called electrolysis. Now, what is electrolysis? Electrolysis is the decomposition of an electrolyte by using current. Now, what I want you to understand, first we have to define some terms. We have to define what is an electrolyte. Now, what is an electrolyte? An electrolyte is a substance that conducts electricity in molten form or either in aqueous form. So we are going to talk about the electrolytes, and then we go to what we call the strong electrolytes and the weak electrolytes. Then we talk about the two terminals of which conducts electricity, which is the cathode and the anode. Then we talk about the different kinds of electrolytes, electrodes that we have, which are the strong electrodes, not strong, inert electrodes and the reactive electrodes. Now, let's start. Okay. Electrolysis are the decomposition of an electrolyte by using electricity or current. And also we said we will talk about what is an electrolyte. So the first thing that we need to define is an electrolyte. What do we mean by an electrolyte? Now, an electrolyte, like we said, is a substance that conducts electricity in molten form or in aqueous form. So what does that mean? Anything that is a solid, that is a liquid, that is a gas, it does not conduct electricity. So for elements or for a compound to be able to conduct electricity, it should be in molten form or in aqueous form. So an electrolyte, a substance that conduct electricity in molten or aqueous form. Now, e.g., we have molten sodium chloride. Molten sodium chloride will conduct electricity, but solid sodium chloride will not conduct electricity. The reason being that in molten form, compounds can be able to release free ions, or in aqueous form, ions are easily ionized in that form. Now, let's talk about the two types of electrolytes that we have. And like I said, we have what we call strong electrolytes. And we have what you call the weak electrolytes. We have strong and weak electrolytes. Now, what is the difference between the two? The difference between these two, the strong electrolytes and the weak electrolytes, is this. The strong electrolytes, they completely ionize in water. Completely ionize in water, which means the weak electrolytes they do not completely ionize in water. Now, let's go to the example. An example of a strong electrolyte, we can have molten sodium chloride. We can also have concentrated concentrated copper 2 sulfate. For now, we'll pick these two examples, molten sodium chloride and the concentrated copper 2 sulfate, or you can even mention aqueous silver chloride. It can also be used as a strong electrolyte. And a weak electrolyte, we can have CaCl, which is called chloromethane. We can have 1,2 dichloroethane. These are weak electrolytes. They do not conduct electricity at all. Either in molten form or in aqueous form, they do not conduct electricity. But the strong electrolytes, they conduct electricity in molten form, concentrated form, and even in aqueous form. Now, what you are left with is to talk about the two electrodes that we have. Now we'll go to the two electrodes that we have. I'll be continuing with like I said, now we'll be talking about what you call the electrodes or the two terminals. Now we have the electrodes, we have what you call electrodes. Now these are the means of conducting electricity. How does electricity reach our solution? Now, the first thing that we have to talk about is the first electrode that we have. We have what you call the cathode, and then we have what you call the anode. Now, the cathode, what is the cathode? The cathode is a positively charged. It is called a positively charged. It is a positively charged electrode. It's a positively charged electrode. And then we have the anode, which is a negatively charged electrode. Now, let me clear something here. Whenever we are dealing with electrodes, we should be careful with one thing. We have two ions that we have. There is what we call an ion. So the ions that we have two of them. We have what we call the cation ions and the anions. Now, what are the cation ions? The cation ions are ions of metals, and then the anions are ions of non-metals. But also they include some little bit of metals there. Now, I want us to look at two things there. We can look at this thing here on this other board. We have what you call a reactivity series. Now, the reactivity series is divided into two parts. We have the cation ions and we have the anions. And then, like I mentioned here, that we have the most reactive elements, and at the bottom there, we have the less reactive elements. Now, look at this. Whenever a substance is electrolyzed, elements that are at the bottom of this reactivity series are the ones that are discharged at every electrode. What does that mean? For example, in the anions, we don't expect that you find when a substance is electrolyzed, then you find fluorine being discharged. No, what is discharged is the element that is always at the bottom. For example, we can always have hydroxide being discharged, and when hydroxide is being discharged at an electrode, it will give out what you call oxygen. Now, when you look at the cation ions, mostly we can have hydrogen being discharged, and hydrogen is going to be discharged as a gas. Or we can have copper, we can have some copper deposit being deposited or being seen on the substance that is being electrolyzed, or on the object that is being electroplated. Now let's go back to our thing here. Now, at the cathode, like I said, always we will find the cat ions. At the anode, always we will find the what we call the anions. Now, let me correct something here. So the cations, they come here, which means our cathode, it is going to be negatively charged because opposite ions attract. So the negative charge will attract the cations because they are positively charged. Because they are positively charged. And then here, the anode is going to be positively charged because the opposite ions attract the opposite. So if the anode is positive, which means it will attract the negative ion, so which is going to come from the anions. The anions are negatively charged, so they are going to be attracted by the positive charge, and then the cations are positively charged, so they are going to be attracted by the negative charge. So now with this, it concludes to what we call what happens at the cathode. At the cathode is either we see some deposits of copper when copper is part of the electrolyte, or we can see a gas being discharged, which is hydrogen, or at the anode, for example, we can have the hydroxide ions being discharged. And what does that mean? It means oxygen is going to be produced or is going to be liberated. Now, let's talk about the two different kinds of electrodes that we have. I said we have the reactive electrodes and the inert electrodes, or we can call them the unreactive electrodes. So the first thing we have the reactive. So the reactive electrodes, and then we have the inert. They're called inert. The word inert just means that they are unreactive. And then the reactive, for example, reactive electrodes are always made by one of these from here. So it's either they're made of lead, they're either made of copper, they can be made of silver, they can be made gold. They can't be made of gold because gold is unreactive. Now the first one, we can have reactive electrodes being made up of what? Lead. And then also we can have electrodes made of what? Copper. And we can also have electrodes made of what? Silver. And then the unreactive ones, for example, the unreactive ones, we can also have platinum there. We are going to have the first one, they are carbon electrodes. They are unreactive carbon electrodes. We have the carbon electrodes. And then we have the second one is going to be the AU made of gold. But the most important ones are the platinum electrodes. The platinum electrodes. So these are the two types we can forget about gold for now. So these are the two electrodes that we have. The inert electrodes, we have the carbon electrodes. They do not take part during the process of what? Electrolysis. But the reactive electrodes, they take part during the process of electrolysis. Now, I want us to move on to what we call what happens at the cathode and what happens at the anode. And also we have to deal with what we call when we have a concentrated solution and when we have an aqueous solution. So we should know what is going to be produced in an aqueous solution and what is going to be produced in a concentrated solution. So all that we need to know is to differentiate between these two words. What do we mean by concentrated and what do we mean by aqueous? The word aqueous, what does that mean? It means that the substance has been dissolved first in water, or it means that there is more water into that substance or compound. But when you say it's concentrated, it means there's more of the substance. For example, concentrated sodium chloride, if we have that, it means there is more sodium chloride and less water. We'll stop here, we'll take it from there next lesson. Now, there are two ways of doing this thing. We're going to look at a situation whereby we have an aqueous solution and we have a concentrated solution. Now, the first thing first, like I said, for us to be able to do these things, we have to be able to know this chart here, where we talk about the cation ions, the reactivity series of cation ions, and the reactivity series of anions. Now, you need to know this thing and even know it with your head without looking at it. Now, like I said, elements that are going to be discharged are elements at the bottom. Elements at the bottom which are the less reactive. Every time in every electrolysis, any substance that is going to be electrolyzed, elements that are at the bottom are going to be discharged. Like I gave an example there. Now, let's say you have, for example, let's start with a situation whereby you have molten sodium chloride. Now, we have molten sodium chloride. Now, all that we need to know here is that we have to first identify the cation ions, and the anions, that are present in this solution. We have molten sodium chloride. So what are the cation ions that we have? We have sodium, and then the anion that we have chlorine, which is -1. Now these are the two ions. So this one is very simple. You don't need to even to think about it, because obviously you know that you have one cation and you even have one anion, so you should say what is going to happen at the cathode. Like we said, at the cathode, we are going to have the cation ions, because the cathode is negatively charged, so it's going to attract the opposite. Now, the first thing first, what is going to happen at the cathode? What happens at the cathode in this solution that we have a molten sodium chloride? So we said that we are going to have sodium, so it's going to be sodium plus 1 plus an electron. We get sodium in solid form. You make sure that you write the state symbols. So we make sure that the equation is balanced. We can see we have one sodium atom this side, sodium ion this side, and one sodium atom this side. Then we have one electron that is going to be lost, and we have one electron that is going to be lost. So this is what is happening at the cathode. That is your equation at the cathode. Now let's look at the anode. We have what is happening at the anode. Now, at the anode, like we said, we have the chlorine there. So we have Cl minus like that. It is going to give us, it's going to be Cl plus an electron. It will give us Cl2, which is a gas. This one is aqueous. So now we should remember that here we are gaining an electron, so our electron is not going to be lost. So we have something like this. We have Cl like that. So we have Cl2 plus an electron. The reason why we move this electron this side is because now we are going to gain the electron. We are not losing it like this side, but this side we are gaining the electron. So we need to show. Now if you look at this equation, it's not balanced. We have Cl, but this side we have 2Cl, so which means you write your 2 there. If you write your 2 there, it means you have 2 chlorine ions, and then you write 2 here. Now, note one thing here. There are 2 chlorine atoms here, so there are going to be 2 chlorines, gaining electrons here. They not one chlorine is gaining, but 2 of them. So that's why we have Cl2, and we have 2 electrons that are going to be gained because we have 2 chlorines. Now, let's look at our second solution. Our second solution now, let's say we have aqueous. Let's say we have aqueous copper. Let's say we have aqueous copper to sulfate. Now, let's look at these things this way. We said the first thing first, we are going to identify the cations that are present and we identify the anions that are present. Now, we write the cations and then we write the anions. Now, I want you to see something. The moment you say something is aqueous, it means it has what? Too much water. So we already have H2O, and we should know when you break down this H2, what you get. You are going to get H plus, which is the hydrogen ion, and the OH minus, which is the hydroxide ion. Now, just from the aqueous solution, and then we have copper and we have the sulfate. Now we know copper is a metal, so it's a cation. So we have Cu2 plus, and then another cation that we have is H plus. Now we have our H plus there, and then we have our OH minus, which is the first anion that we have OH minus, and then we have our sulfate, which is SO4 2 minus. Now this is the tricky one. We have 4 ions that are present, and we need to know which ion is going to be discharged at the cathode and which ion is going to be discharged at the anode. Now, first thing first, we start with the cations. What is going to happen at the cathode? Now, like I said before, you can never ever answer this question if you don't have this. So the first thing that you need to know is to know the cations that you have. So we have 2 cations. So following, we are going to check between copper and hydrogen, which one is going to be released. The one that is at the bottom is going to be discharged. So we have hydrogen here, and then we have copper here. So what does that mean? We said the one that is less reactive, which means hydrogen is less reactive, is more reactive than what? Copper. So copper is what? Less reactive than hydrogen. So copper is going to be what? Discharged at the cathode. So we have Cu2 plus an electron, meaning that you are losing an electron. So you have Cu, which is going to be a solid. And then you should know that there are 2 electrons that are being lost here. So you balance your equation, you have 2 here. So you have 1 copper ion this side you have 1. So the equation is balanced. And then you write that this one is going to be aqueous. And then we have the anode. We have the anode. Now, what is going to happen at the anode? We check our anions. So we look at our reactivity series of the anions. So we see that we have sulfate. It is the one of the most reactive ion that we have. And then we have OH, which is the less reactive. Like we said, the one that is less reactive is going to be discharged. So we know that at the anode, we are going to have what? OH minus, which is going to be discharged. And then that OH minus is aqueous. Then what do we get? We get H2O plus oxygen plus an electron. Now, when we have an equation like this, the equation is not balanced. So we have to balance the equation. We put a 2 here, and then we have 4 hydrogen atoms, then we have 4 oxygen atoms. So we put a 4 here, and then, which means when we put a 4 here, we have 4 ions for all of these. So 4 electrons are going to be lost. We also mentioned that we have a gas being produced here, and then we have a liquid, and then we have this OH minus as in aqueous form. Now, in conclusion, what are we saying? If a question can come asking you what is going to happen at the cathode and what is going to happen at the anode. Now, the moment you say you are going to have copper here as a solid, now what does that mean? It means, for example, when you are electroplating, you are going to have copper covering the substance that you, not the substance, but the object that you are electroplating. So how do you see that it is copper when it's copper, you see some brown deposits. Now, what can you see at the anode? The moment you write that there is O2 that is produced, which is a gas. So it is going to, what you can see first is what you call effervescence. And what is effervescence? Formation of bubbles. And that is what is seen or what is observed at the cathode and what is observed at the anode. And thanks for your time. And I love you guys.